Hello guys, so welcome to another brand new video of Geomaniac. So in this video, I'm gonna explain about the basics of igneous petrology within 10 minutes. So let's get started. So first of all, we're gonna discuss about the igneous rock types. Before that, we know that igneous rocks are resulting from the cooling and consolidation of molten material called magma, which is generated in the deeper parts of the earth. Formation of igneous rock is one of the earliest and primary earth processes which play a vital role in the growth and evolution of solid earth. Hence, systematic study of igneous rock, that is igneous petrology, constitute one of the fundamental branches of geology. So, now let's get into our topic. There are basically three types of igneous rock. One is plutonic or intrusive, the second one is volcanic or extrusive, and the third one is hyperbasal rocks. The plutonic rock are formed deep inside the earth crust by the slow cooling and solidification of magma under great pressure and retention of volatiles. While in case of volcanic rock, they are formed at the Earth's surface by the eruption of lava. The cooling is usually too rapid, so minerals are aphanetic and glassy. The third one is hyperbasal rock. The hyperbasal group include rocks of dikes, sills, and small laccoliths, etc., which occupy an intermediate position in the crust between the deep-seated plutonic bodies and the superficial lava flows. So next we are gonna look on to the forms of igneous rock. On the basis of mode of occurrence, the igneous bodies are divided into extrusive when formed on Earth's surface and intrusive when formed within the Earth. The extrusive form may be a product of cooling of molten lava or solid products ejected from volcanoes, and the intrusive forms are further subdivided into plutonic and hyperbasal on the basis of their depth of occurrence. Large intrusions formed at the moderate to great depth are called plutonic bodies, and small intrusions formed near the Earth's surface are called hyperbasal bodies. So, through this flowchart, we could understand more about the way how it is divided and subdivided into different structures and forms. Next, we are gonna look on to the structures of igneous rock. They are dependent on several factors like composition of magma, viscosity of magma, temperature, pressure, and presence of other gases and volatiles. So, the different types of igneous structures include mainly five types, that is block and rupee lava. It is basically a basaltic lava, and then comes the vesicular and amygdaloidal structure. These are actually small vesicles or empty cavities present in the volcanic rock. This is called as vesicular structure, and when these spaces get filled with the secondary minerals, it is called as amygdaloidal structure. Then comes the pillow structure. Pillow lavas are formed when the basaltic magma comes in direct contact with water or other water saturated sediments. And then comes the flow structure. These are planar or linear features that as result of the flow of lava. Then comes the joints, that are cracks or fractures developed in rock that divide the rock into parts or blocks. There are different types of joints such as sheet joints, mural joints, rift and grains, columnar, etc. We are gonna learn about the textures of igneous rock. Texture of igneous rock describe the size, shape, and mutual relationship between the mineral grains or that between mineral grains and glassy matter present in the rock. An accurate description of texture requires consideration of 4 points. They are degree of crystallization, second, size of crystal or granularity, then shape of crystal and mutual relationship of individual grains. In case of degree of crystallization, crystallinity is measured by the ratio between the crystallized and non-crystallized matter. On the basis of degree of crystallization, textures of igneous rock can be divided into three groups. They are hollow crystalline, which is the rock is made entirely of crystals. Then comes the hollow hyaline, when the rock is composed entirely of glassy material. And the third one, hemicrystalline, when the rock is composed partly of crystal and partly of glass. Then comes the grain size or granularity. Grain size in an igneous rock varies considerably. It ranges from several meters to less than zero point 0.0 millimeter. So, mostly described terms are pheneric. It refers to rock in which individual mineral grains can be seen with the naked eyes. And then comes the aphanetic. It refers to rock in which individual mineral grains are not visible with the naked eyes or without a microscope. As per shape of the crystal, mineral grains are classified into three: euhedral, subhedral, and anhedral. In case of euhedral crystal, it is used when mineral grains is having a well developed crystal phase. And in subhedral crystal, if the mineral grain is having partially developed phases. And anhedral, if the grain is having an irregular crystal phase. Next comes the mutual relationship of grains. It describes the various patterns of crystal arrangements and the mutual relationship of the grains. In that case, it is divided into equigranular texture and inequigranular texture. In equigranular texture, it comes allotriomorphic, hypidiomorphic, and penidiomorphic. In allotriomorphic, most grains is anhedral, and hypidiomorphic, most crystals are subhedral, and penidiomorphic, most grains are euhedral. In case of inequigranular texture, first comes the porphyritic texture. In porphyritic texture, large crystals are enveloped in a fine grained matrix. These large crystals are called phenocryst and fine grained material called ground mass. Next is poikilotic texture. Here small crystals are enclosed within larger crystal without common orientation. And then comes the ophiolitic texture. In this texture, plates of augite enclose numerous thin laps of plagioclase. The other types of texture include directive texture. It is a texture which is produced by the flow of magma during the progress of crystallization. Then comes the intergrowth texture. This texture is mainly formed due to simultaneous crystallization of two minerals from magma. It is subdivided into two types, that is, one is graphic texture. Graphic texture consists of intergrowth of quartz and alkali feldspar. Then comes granophyric texture. Here it is the intergrowth between quartz and alkali feldspar and not regular as in case of graphic texture. Then it is called granophyric texture. And then comes the myrmetic texture. It is an intergrowth between quartz and plagioclase feldspar. Here, quartz plagioclase intergrowth are commonly found to be in contact with potash feldspar. And then comes the exsolution texture. Here, intergrowth of two minerals formed by the exsolution. Then another type of structure is the reaction structure, which often take place between early formed mineral and the surrounding magma. Then comes the orbicular structure, especially it is seen in granitic rocks. There occasionally occur a ball-like segregation consisting of concentric shell of different mineral composition and texture. Then comes the spirulitic texture. It is composed of an aggregate of fibrous crystal of one or more minerals radiating from a nucleus with glass or crystal in between. Then the last one is the perillitic fracture. Perlite is a natural hydrated volcanic glass that displays concentric onion skin like fractures in hand samples or in thin section called perillitic fracture. It is formed by the rapid cooling of viscous lava or magma. So that's all for today's video, guys. I will be uploading another video which will be revolving more about the mineralogy as well as process of mineral crystallization as well as magma formation in the upcoming video. So this is just an overview or just basics about the igneous petrology. Hope you all understood, and don't forget to subscribe, like and share.